So as you guys know, I am not there today. I'm at a meeting doing the school improvement plan. So this is a way that you guys can take notes even without me there. Now you don't have a notes handout to fill in, but by doing it this way, you're able to pause the video if you are not able to keep up with the notes, and you can write down the information that you need to get written down on each slide that way. I am expecting that you still take notes. You're going to need to use this information on the assignment that follows, and you're going to need to know the information for the test. So here we go. There are two different types of waves. The first type of wave is a transverse wave. Okay, transverse waves are what you typically think of when you think of a wave. So the particle motion is perpendicular to the wave motion. So the particle motion goes up and down, whereas the wave motion goes left to right. So some examples of transverse waves are light waves or secondary earthquake waves are transverse waves. You'll notice we have the crest, that's the high point of the wave. The trough is the low part. The wavelength is crest to crest, trough to trough. Wavelength can also be this, that's one complete cycle. And amplitude is from the midline to the crest or the midline to the trough. The second type of wave is a longitudinal wave. So this time our particle motion is parallel to our wave motion. So our particle motion is left and right, and our wave motion is left and right. Some examples of longitudinal waves are sound waves and primary earthquakes. Now, when we look at a longitudinal wave, the areas that are tight together we call compressions, and the spread out areas are called rarefactions. Now, wavelength goes from a point on one wave to an identical point on the next wave. So if I go from the middle of a compression to the middle of a compression, middle to middle, that's a wavelength. If I go from the middle of a rarefaction to the middle of a rarefaction, that's a wavelength. I can go from the beginning of a rarefaction to the beginning of the next rarefaction, and that can also be my wavelength. So, wave parts, the crest is the highest point on the wave, the trough is the lowest point on the wave. Wavelength, which we symbolize with the Greek letter lambda, is the distance from some point on one wave to the same point on the next wave. Amplitude is a maximum displacement from equilibrium. Compressions are areas that the particles are tightly packed, and rarefactions are areas where the particles are more spread out. This should not be new. This should all be reviewed from 7th grade. In fact, I know you did this in 7th grade, okay? So what you're going to see is throughout the rest of your school career that retaining that information that you've previously learned is really important. So please make sure that you're doing that. So when we talk about waves, we can talk about period and frequency and wavelength and wave speed. So there's a lot of different things for us to look at here. Period is how long it takes for one cycle to occur. So that is how long it takes for one of these. It can be for one of these. It can be one of these. I don't know why that straight up line went there. One of these. Okay, that's one cycle, one complete wavelength. Period is measured in seconds, and it's symbolized with a capital T. Now, frequency is the number of cycles per second. So, oops, sorry guys. If this symbolizes 1 second, I would have 1, 2, 3, 4, 5 complete cycles in 1 second. So it would be 5 hertz. And it's symbolized with a lowercase f. So these are inverse functions of each other, meaning as one gets bigger, the other gets smaller. So period is 1 over frequency, or this should not be capitalized, it should be a lowercase f. Frequency is 1 over my period. Wave speed. The speed of a wave, sound or light wave, does not matter, depends on the type of medium that it's traveling through. And you should have read something about this when you did your articles on pages 7, 8, and 9, maybe 10. Yeah, 7, 8, 9, and 10. So medium is just a sciencey word for material. So sound travels more quickly through a more dense medium than a less dense medium. So what that means is a more dense medium would be a solid, and a less dense medium would be a gas. I don't know why that keeps happening. Light travels more slowly through more dense mediums. So light does the opposite of sound. It travels much, much slower in solids than it does in gas. Because of this, we see light doing something that we call refracting when it changes material. So for example, if you are spearfishing, here, maybe I can change my color so this actually looks like water. Yep. If you're spearfishing, okay, and you're looking down into the water, you maybe see that the fish appears. Okay, this is where my fish actually is. This is my real fish. Now, you see a fish as if it's down here. This is the apparent fish. So when you go to spear that fish, you're going to miss the real fish. Okay, that's because light bends when it travels from air into water or water into air. And remember, your eyes are in the air. So light has to go through both of those mediums for you to see the fish. We can find the speed of the wave if we know its wavelength and its period or its frequency. Remember that those are opposites of each other, so if I know one, I can always find the other. So we can use the equation V equals wavelength over period. And I'll make circles for you. Or we can use the equation speed is wavelength times frequency. Now, with that, I can also do one for frequency and period. Oh my goodness, that's so annoying. Frequency 1 over my period. These are key. You're going to need to know these for your assignment today. And that's where we get to end. So, now you are responsible for completing pages 11 and 12 in your packet. And those will be homework and they are due tomorrow.